Welcome to a summertime overview of the nighttime sky. Um, as you can see in the lower right-hand corner, I've got the sky set for 11 o'clock at night on July 1st. Of course, we know summertime is not just 1 month at one time, but I thought it would be best to pick something fairly early in the summer. So it'll be fairly close to the time that you might be watching this if you watch it after I soon publish it, but would also be applicable a little bit later as well. So I'm going to go through the sky at this time, highlight a few of the prominent constellations and stars, and a few objects that you can spot with binoculars as well. First off, we should say goodbye to a couple springtime constellations that you can see setting in the west. Again, if I change the date and the time, I'll try to make a note of it, but you can always check down here to see what the current date and time is for the screen. But the constellation Leo and the constellation Virgo are setting at, this is 11 o'clock at night, so a little bit before this, they'd be higher in the sky, of course. But Leo the Lion, the bright star in Leo, is Regulus. And for Spica, for the constellation Virgo, the bright star is Spica here, south of west. If we go up a little bit higher in the sky, this is something that isn't quite a year-round star and constellation, but it is above the horizon for a very long period of time, on average, every day throughout the year. But that's Bootes and the bright star Arcturus. Arcturus is the third brightest star visible from, it's virtually tied with Vega as the second brightest star visible from the northern part of the United States. It's basically tied for fourth overall behind Sirius, and then two stars that are in the farther down in the southern celestial hemisphere. An interesting object to find in Bootes is Messier object number 3. So the way to find that is to first find Arcturus. So Arcturus is a bright orangish star. And then to the, as we see it right here, to the right of it is the constellation Canis Funada. This is a fairly bright star. If I click on it, I can get the name of it. It's the Alpha star, the brightest star in that constellation. It's a variable star called Cor Caroli, meaning that its brightness varies. It's not super prominent. So one thing you might want to do to help you find what I'm about to show you is, instead of first going to Cor Caroli, go to the Big Dipper. So kind of with the naked eye, without binoculars first, kind of pass from Arcturus all the way to the bottom of the Big Dipper cup. About halfway there is going to be this star Cor Caroli. About halfway between Arcturus and Cor Caroli is the object that we're definitely going to need binoculars to see, and that's Messier object number 3. So we're going to zoom in, and it's good to try to get the lay of the sky with your naked eye before finding it with binoculars. So kind of get the flow across here. So then get the flow from Arcturus to Cor Caroli. And then you're ready to, with binoculars, kind of sweep across the sky. So I'm going to zoom in. Now we can see the constellation name pops up. And you can see this little hash mark here. That is Messier object number 3. So the third object in Charles Messier's catalog. It's a globular star cluster. So it's a cluster of a few 100,000 stars. It's one of the brightest ones in the nighttime sky. The best way to find it, and I'll close this off, is again to practice moving your binoculars from Arcturus to Cor Caroli. For typical binoculars that have a field of view of about 7 degrees, this is approximately 2 binocular fields of view from Arcturus towards M3. And so that is going to be right above sort of a dim star here. So the best way to find this is to get Arcturus at the left-hand side of your binocular field of view, then kind of move your binocular field over your binoculars over another binocular field of view. And you should see what looks to be kind of a fuzzy, unfocused object right above a star of roughly similar brightness. With binoculars, you're probably just going to detect it as a fuzzy, unfocused object. But as we zoom in, you'll probably see it. It'll sort of have this kind of feel to it. Crisp star, something sort of fuzzy. Obviously, you won't have the blue circle around it. If you did have a larger telescope and zoomed in, it would actually resolve into many stars. As I said, hundreds of thousands of stars. Even with a good earthbound telescope, the stars are so close together and so far away from you that they just meld into one big clump of stars. So we'll zoom back out. And by the way, in the upper corner here, this FOV, field of view. So you can see roughly how big the field of view is. So as we move over, we can see a few more prominent constellations. Oops, that was a little bit of a jump out there. Libra, which doesn't have a lot of bright stars in it. The moon shows up here. The moon is obviously not going to be in this location from night to night. If I step forward another night, the moon would be in a drastically different location, whereas nothing else on what you see here would change. But in the southern sky, we've got Scorpius, we've got Ophiuchus, which is the 13th zodiac constellation. Leo is off of the field of view, Virgo, Libra, Scorpius, Sagittarius, Capricornus. Those are all constellations you've heard of. Those are signs of the zodiac. Strictly speaking, those are the constellations through which the sun appears to pass as the Earth goes around the sun. The sun actually goes through 13 constellations. It goes through Ophiuchus as well, but 13 has always been an unlucky number. In many cultures, people didn't want 13 constellations, so Ophiuchus got demoted to interesting constellation, but not a zodiac sign. Another summertime constellation is Hercules. You can see Hercules here, bright, prominent constellation, and Lyra. Lyra has the bright star Vega in it. Vega is one of 3 stars in the summer triangle, which I will highlight in a little bit. But I want to highlight a few objects that we're seeing in the constellations that I just showed you. I showed you Messier object number 3. That one is a little bit difficult to find because it's sort of in the middle of a region without any bright stars. Hopefully I guided you there reasonably well. But when you look for something in the sky, it's always nice to have an easy marker. The brightest star in the constellation Scorpius is Antares. Right next to Antares in your binocular field of view is Messier object number 4. So I'm going to shrink this down so it's roughly a typical field of view of binoculars. So this says about 6.4 degrees. So just less than a degree, I would say, away from Antares is Messier object number 4. That is not quite as bright of a globular cluster. And it's also in this background. Notice as I zoom in, you kind of have this haziness. That's because right here we're looking directly into the thickest part of the Milky Way galaxy. So there are a lot of stars in this region, and then there's also a lot of dust in this region too. It's illuminated, but still pretty easy to see M4. Again, it will look like a slightly out of focus star with your typical pair of binoculars, but this is one of the easiest Messier objects to find, and certainly one of the easiest globular clusters to find. Antares, by the way, is a red supergiant star, Antares is a star that is near the end of its life. It is so big, you hear the word super and you wonder, well, what does that mean? A super giant? It's really giant, right? That star is so big that if it were to replace our sun in the solar system, it would fill up the entire inner solar system almost out to the planet Jupiter. So it would swallow up the orbits of Mercury, Venus, Earth, Mars, and the inner asteroid belt. That's how big that is. And I'm not going to highlight all of these things. And by the way, this is, you can see the URL, stellarium-web.org. Then this is a great free program. But you can see a lot of symbols here. Here's M19, this cross hatch, that's the symbol for globular cluster. So this is another globular cluster. Down here we've got M6 and M7. Those are open star clusters. This region of the sky has a lot of interesting binocular and small telescope objects. As I move up to Hercules, Hercules has this keystone shape. And you might be saying Hercules. Okay, I've heard of Hercules, but I don't really see Hercules in this. There are a lot of different ways to picture the constellations, but here is one version. So this is showing Hercules upside down with the keystone being basically his lower torso, and these being his legs splayed out. I've also seen other pictures where these star lines of stars that represent his legs here represent his arms in a different version. So astronomy art is really, or constellation art, I should say, is really subjective. So if you want to find the next object here with binoculars, best thing to do is to start with Vega. Again, nearly tied with Arcturus as the second brightest star that can be seen from the northern part of the United States. It's in the constellation Lyra, the small harp. So start with Vega. And M13 is what we're going to be aiming towards. So if you move Vega over, so you're finding binoculars, with binoculars you're going to find it. So start with Vega, and you're going to kind of shift over towards the keystone here. Vega is a bluish star, and if you ever saw the movie Contact, one of the characters in the movie Contact that reaches out to the main character, that living being came from a planet that is orbiting Vega. Vega is pretty common in science fiction because it is such a bright star. But anyway, back to the real world. So starting with Vega, find Vega with your binoculars. You might need to nudge your binoculars over just a little bit. Actually, let me show you the full path, and then I can model the star hopping when I zoom in. So you'll kind of hop to this star here. Roughly the same distance away is this corner of the keystone. You'll know when you're there because you'll see this longer skinny triangle. Then you can hop up to this corner of the keystone. And then as you move from this corner of the keystone, the upper right corner, to the lower right corner as we see it here, you'll pass by M13. So let's zoom in. Sorry, this might be giving you a little motion sickness there. All right, so I've got the field of view here of about 6.5 degrees. So we've got Vega in one corner of the field of view, and then we spot this star right here. And we know we're going in the right direction when about halfway between, we see these little twin stars right here. So now we're going to move our binoculars in roughly the same direction. So we're going to move the star that we hopped to after Vega to one part of our binoculars, and then go to the opposite side of our binoculars, and there's our little triangle that we found. And just to make sure that you know it's the right little triangle, the proper little triangle. It's not a right triangle. The proper little triangle, there are these two stars, really dim stars below the most lonely of the triangle stars. So now you're going to move that down to the edge of your field of view. Move on to this star, which I labeled as the upper right-hand star. And if you move that to the top of your field of view, in the middle of your binocular field of view should be M13. M13, I think, is one of my go-to sort of easy to find, but sort of challenging to find objects in the sky. M4 wasn't terribly challenging because it was right next to, in the sky, the bright star Antares. And when I say right next to, I actually mean, unless I say otherwise, I do mean right next to in the sky. Antares is much, much closer to us than M4 is. Globular clusters are on the order of tens of thousands of light years away, where stars are on the order of tens or hundreds, or maybe a few of them, maybe 1,000 or 2 light years away. But globular clusters are 100 times or more farther away than the typical star, bright star that we're looking at. Again, if we had a small telescope, we would zoom in and we would see a clump of stars. When we zoom in and you see these HD with the numbers, those are stars from the Henry Draper catalog. HD is just the abbreviation for the catalog. So nothing super special about these stars. This is interesting. So NGC is another catalog. I believe it's New General Catalog, 6207. This is a galaxy. Let's just click on this information for a second. Oops, so that actually, when I clicked on some very specific star. So the magnitude of M13 is 5.78, so basically 6. That means it's at the edge of being able to be seen with the naked eye. And for something like this, maybe somebody in a really dark site who has really exceptional eyesight could see it. But for the most part, it would be virtually impossible for anyone to see if there's any sort of light pollution or any sort of slight haze in the air. There'd be just a handful of people and a handful of sites in the world that could see this with the naked eye. With binoculars, you're definitely not going to spot this galaxy, this spiral galaxy. Notice it has a magnitude of 11.63. So that's about twice as big. This was a little under 6. This is a little under 12. The larger the magnitude number, the dimmer the object. This, even though it's a galaxy, which is billions of stars compared to a few 100,000 stars, this is so far away from us and so dim that there's no way you could see it with binoculars. Even a medium size, maybe a telescope that you'd get from a catalog for $1,000 or so, depending on the quality of it, depending on the eyepieces and so on, you might have a difficult time seeing the galaxy with that as well. But rest assured that when you are looking at M13 in your binoculars, there is at least one other galaxy in your field of view. So I'm going to zoom out here. So I directed you from Vega, as I zoomed out, you saw Corona Borealis. So the crown, and when I showed you the picture here, there is the crown. One of our former students, he liked to find M13. He imagined Corona Borealis as a half pipe, like if you're snowboarding or skateboarding and you follow the half pipe, and when you come off the half pipe, you end up with at M13. So I'm not young and hip enough to know about half pipes, so I don't use that as a guide. So let's move over to probably the best object in the nighttime sky to just scan with binoculars, and that is Sagittarius. Again, we're still at 11 o'clock on July 1st. At 11 o'clock on July 1st, we see two bright planets, Jupiter and Saturn. Those will remain roughly in those positions throughout the whole summer. They'll move a little bit from night to night, but pretty much stay in that spot for the whole summer, again, as opposed to the moon, which will be in a drastically different location. But Sagittarius has all sorts of different and interesting objects. So notice as I zoom in, there are star names here, but we've got M7, M6, which we saw before. Here's another NGC 6553, M8, M24. This is such an interesting direction of the sky to look because this is the direction of the center of our Milky Way galaxy. So there's going to be the highest density of stars in the center of our Milky Way galaxy, and also globular clusters orbit around the center of our Milky Way galaxy. So there will be a disproportionate number of globular clusters off in this direction as well. So a few interesting binocular objects. M22 is another globular cluster that is fairly easy to find because it is just to the right of the top of Sagittarius, which some people say looks like a teapot. There's the handle of the teapot on the left. There's the spout of the teapot on the right. So you can zoom in with your binoculars, find M22 fairly easily. If you go from the top of the teapot up to this star above it, and then a little bit off to the side is M24. So the small Sagittarius star cloud, also known as M24, as I said. So that, you see the magnitude here is 4.59. That's even brighter than the globular cluster in Hercules. But when things are spread out, even though they have a bright, their magnitude number is small, meaning they're brighter, that doesn't mean that they're necessarily that much easier to see because that light is spread out more. By the way, two things. So smaller numbers mean brighter. Doesn't really make sense, but think of the word magnitude. So magnitude is a rating of the brightness of the star as we see it. Things that are really important are considered, they have a value of the first magnitude. Something that's a little bit less important has value of the second magnitude, and so on. So that's the history of smaller number, meaning brighter object. So that's up above this star right here. And that is probably one of the most interesting and easy to spot binocular objects that is not a globular cluster. Off to the side here, we've got M20. M20 is an open star cluster and nebula, so the Trifid Nebula. Nebula are typically a little bit more difficult to see. The Orion Nebula, which is a wintertime object, is easy to see with the naked eye. Most nebula are a little bit too diffuse. This is one that in binoculars, it will stand out as looking different from its background, but it's not going to just jump out at you. This region of the sky here, you can see this is filled with star clusters and nebulae. So Herschel's 36, another catalog, open star cluster. Again, brightness 4.59. So this is the star cluster here. That star cluster is actually within a larger cloud area, nebulous area, that is called M8, the Lagoon Nebula. So this area of the sky, oops, wrong way. This area of the sky has the Trifid Nebula and the Lagoon Nebula. And if we're at sort of our standard binocular field of view, they will be pretty close together. So those are interesting objects to look at as well in binoculars. They won't be quite as exciting if you have a small telescope. That would be much more interesting to spot. So this being a tour of the summertime sky, it makes sense to zoom out now and, oopsie, sorry, I was looking in the wrong area. Zoom out to the summer triangle, which consists of Vega that we visited before, Altair in the constellation Aquila, and then Deneb in the constellation Cygnus the Swan. You can see that the summer triangle is sort of low in the eastern sky at 11 o'clock. So to say that something is a summer, whatever, the summer triangle, a summer constellation, that means that it's rising in the summertime and it's prominent in the sky for most of a summer evening. In the middle of the summer triangle are two interesting objects. So pretty close to right in the middle, this sort of bright star. As I zoom in, you can see, oh, well, okay, it's a bright star, kind of boring, kind of boring. But as we zoom in enough here, you notice that that bright star actually resolves into two stars. That star has the singular name Albireo, but it is a double star system. So I think I actually clicked on Albireo B, basically Beta Cygni, the one of the two stars, and I'm not sure if I zoom out enough, it should just tell me, yep, Albireo before, and it gives me the magnitude of 3.2. When I had zoomed in before, I had actually clicked on one of the two stars in the binary star system. What's interesting about this star system, the animation, or the sort of, it's not really an animation, the cartoony simulation of it doesn't quite do it justice. You can sort of see that one of the stars is a bluish star and the other one is more of a yellowish star. What's interesting then is these two stars orbit a common center of mass and they are different colors. They have different surface temperatures. So zoom out again. So now we're going to be looking in the summer triangle, but we're going to look at the border here of the triangle. So Altair and Vega make one side of the triangle. As we pass our gaze up that side of the triangle, we're going to stop about a third of the way up, sort of near the end of Sagittarius, the arrow. So as we do that, we move up. We notice something kind of coming into view here. That is a star cluster, and I don't know if it's actually going to, doesn't look like this program shows us its name, but we've got a straight line here. We've got a hook, kind of looks like a coat hanger. So this is called the coat hanger cluster. It's not, though, a true star cluster. Star clusters, and I didn't say this before, those are actually clusters of stars that are near each other in actuality, not just near each other in the sky. A few of these stars are near each other in actuality. And when I say near each other, they could still be a few light years apart, but they might be hundreds of light years from us. So they're much closer to each other than they are to us. That's what it means by near each other. A few of these stars are quote unquote near each other, but a few are not. So actually probably should have thought this one out before I said it, but in hundreds of thousands of years, probably, certainly millions of years, this will no longer look like a coat hanger because the stars have different motion with respect to each other. So that's a tour of some of the summertime constellations. I'm actually going to give you a little trick here if you want to sound smart about the nighttime sky, and that is to commit to memory some of the circumpolar constellations. So those are constellations that orbit the North Star right here, because circumpolar constellations are always going to be above the horizon. Some of the good bright ones are Cassiopeia, Cepheus, Ursa Major, which contains the Big Dipper. Ursa Minor, which contains the Little Dipper, and Draco, the dragon. I want to first focus on Cassiopeia and actually do most of my focusing on Cassiopeia. So Cassiopeia is this W-shaped grouping of stars. And as we zoom in, we start to see a little shape here, this Chi Persei with the dotted circle, which indicates open star cluster. But if you go from the middle star in the W to the second star as viewed from the left, and extend that out about, let's call that a unit of 1. If we extend it out about 2 units, we get to a really rich region of the sky. And it's actually called the double cluster. The double cluster consists of 2 star clusters that are really close together. Each one has a few thousand, or together they definitely have a few thousand stars. So each of them individually has half of a few thousand stars. I don't know if that quite defines as a few thousand or not, but this is probably one of the best binocular objects. A lot of people think I need to buy a telescope in order to enjoy the nighttime sky, but binoculars, a telescope gives you a good zoomed in view, but sometimes you need to see things broader. So if you're looking at a really fancy garden and you try to look at that fancy garden with a microscope, you're not going to see much of that fancy garden. A microscope would not enhance your view of the fancy garden. In fact, it would detract from it. So there are some objects, I would argue that this is one of them, that looking with a larger telescope detracts from your view of a larger open star cluster. Binoculars are almost the ideal tool. Again, Polaris, so you can see that's right above the N here for due north. Oh, and by the way, it's hidden behind a virtual tree here, but Capella is for where I live here in Ellensburg, Washington. It's the circumpolar star that seems to hug the horizon the closest. It almost looks like a spotlight on the ridge north of town, or some sort of a street lamp if there are actually streets up there. But it's a star that doesn't quite dip below the horizon. If we zoom in on the star and the Big Dipper handle at the bend of the handle, we see it says Messier. Okay, that's pretty cool. That's what it looks like at a glance. But if we zoom in even more, we see another star become fairly prominent, and that is Alcor. So Alcor and Messier are also known as the horse and the rider. They form part of a naked eye double, well, they form the whole of the naked eye double star system. You have to look fairly carefully without binoculars. With binoculars, it definitely jumps out as 2 stars. I don't know if this simulation will, yep, so if we zoom in even more, Messier with a small telescope also resolves as 2 stars. If we use even larger astronomical instruments, it turns out that both stars in Messier and Alcor itself are binary stars. So what I like about this is at a glance, this star in the Big Dipper handle looks like 1 star. You look a little bit closer, oh, okay, I can see it's 2 stars. You look with a small telescope and you can see that it is 3 stars. So I probably shouldn't be using the word it is something because I keep changing what it is. It appears to be 3 stars. And then with even larger astronomical instruments, each of those 3 resolves into 2 as well. I've been talking about binoculars a lot. I definitely encourage you, if you don't already, to get a decent pair of binoculars. For $100, you can buy a quite good pair of binoculars, and if you take care of them, they'll last for decades, and you can use them for so many different things. Obviously, looking at the nighttime sky, but you can bird watch, you can spy on your neighbors, you can watch a sporting event, and so on. if you have a birthday wish that you can cash in, why don't you wish for some binoculars? Or instead of wishing, you could maybe work a few extra hours. If you're a kid, do a little bit more around the house or in the yard, and maybe you can earn half of it and have your parents spot you the other half for a pair of binoculars. And then this website, stellarium-web.org, is a good free resource as well.